Now, in a lot of different videos in this course, I've made mention about references, and we've talked about pointers and pointer terminology and so forth. And in this video, I want to kind of back up just a step and start down the path of talking about a couple of topics that you're going to read about and hear about, and they're going to potentially confuse you. All right, because they confuse everybody. And this is a topic that with these references that even a lot of fairly competent, experienced C++ programmers continue to be confused by. And let's talk about in this video, what exactly is a reference? Well, a reference is an alias. Now, that is a name that can be used to refer to something else. Now, be careful, we're not talking about a pointer here, we're talking about a reference. It is another name for the same thing, all right? You can call me Mark, you can call me a trainer, you can call me all kinds of other names, all right? I'll answer to a lot of those names, but all those names are just different names for the same thing, the thing being me, all right? Now, let's take a look at a very simple example here in C++. Notice we have our integer main function right here. This is where the program's going to begin operation. We're in this main function, we're creating integers x and y, and then we're using them as arguments that we're passing to this function called do this. All right, so integers x and y. Now in our function do this up here where we're creating it, notice we're taking in the arguments that are passed into it when it's called, and these are integer I and integer j. All right. Then once we get inside here, we're just basically swapping the values of these. All right. But here's the bottom line here. I and j are references for x and y, because x and y is what we originally have when we're calling our function called do this. But when they get up here, x basically becomes a reference for I, and y, well actually I becomes a reference for x, and j becomes a reference for y. Now we're talking about the same thing. When you change I, you've changed x, and when you change j, you've changed y. All right? So that's what a reference is, and that's the best way to think about them. Now it can get a little bit more complex when we're talking about different types and objects in C++, but if you can get that, you've got it. All right, now here's where it gets a little tricky and confusing. There are two kinds of references in C++. There is an Lvalue reference and an Rvalue reference. Now what's interesting is there's a lot of debate about exactly what these things are, and you can look in a lot of reputable locations and see definitions that will get confounded or confused or even downright shot down on other places. So if you get confused by these, welcome to the club, all right? Because I'm going to talk about these in separate videos to try to help and make sure that I don't confuse you. So we're going to do a separate video on L values, separate video on R values. We're not talking about a lot of information here, just some very simple examples to help you understand exactly what we're talking about. Now what's interesting about this L value and R value stuff is the descriptions are not even very plainly laid out in the C++ standards, and the descriptions of what these are has changed somewhat in the various standards. Okay, so anyway, join me in the videos called L value references, and then in a separate video called R value references, and we'll dig into these just a little more. Now the concept of L-value references is something you're going to read and hear about in C++, and I want to try to explain them to you here. Now understand that we have L-value and R-value references. We'll talk about R values in a separate video, but in C++, every expression is either an L value or an R value. Now when you look at the C++ standards and you kind of dig into this a little bit, you find out that an L value is basically anything that refers to an object that persists beyond a single expression. There's another way to say that, and that is if it's an object that has a name, then it is most likely an L value. Now notice I said most likely. All right. Now all variables, even including constants or non-modifiers, are L values. Notice in this example we've got an integer x equals 1 plus 2. Now x is an L value for a couple of reasons there. Alright, first of all, it's an object with a name. It's an x. It's a variable. And it's got a name x, and it refers to a particular value stored in memory. Alright. The next thing is it's on the left side of the equal sign. And quite often L values, you will find them on the left side of the equal sign. Now that's not necessarily in concrete, and it's not necessarily the main condition for being an L value, but that's kind of an easy way to remember it. Now x is an L value. I've already mentioned it persists beyond the expression that defines it. So once we move to the next line after integer x equals 1 plus 2, x is still going to be around. Now 1 plus 2, as far as this program is concerned, is not around anymore. Alright, the concept of 1 and 2 is still around, but 1 plus 2 has been used and it goes away. Alright, but x still persists. Now again, this can generally be thought of as left value. Now that's what L value is. Now I would strongly recommend, when you're more comfortable with C++, and if you're already fairly comfortable with it, go out on the internet and dig around a little bit about the difference between L value and R value. Okay? Now this is not something that you're generally going to sit around and when you use an expression think, well, I'm working with an R value here, or I'm working with an L value. But this topic will come up from time to time, and it could affect the way that you use certain things and the way you plan on using certain things down the road. So I just want you to understand you're going to see this, and I want to try to give you a little bit of a foundation on what exactly they're talking about. R value references are kind of the more confusing of the R value and L value reference relationship. Now I've already mentioned in a separate video where we talked about what are references, that there are two kinds of references in C++. There's L value and R value, and I talked about L value in a separate video cleverly entitled L value references. And so now let's turn our attention to R value. Now I already mentioned this, every C++ expression is either L value or R value. So what exactly is an R value? Now this is very interesting. If you look in the C++ standards, R value is really not defined very specifically. It does refer to an object that does not persist beyond a single expression. Usually that object does not have a name. If we look at our little sample equation here, integer x equals 1 plus 2, then 1 plus 2 is the R value here. X refers to an object, a variable, and so it is an L value. Now be careful, you can't just go by the L values on the left and the R values on the right, but the real bottom line is, and it even kind of says this in the standard, what is an R value? Well, anything that's not an L value. Alright? Now if I try to set 3 equal to x, thankfully it's going to throw an error. It will not compile. C++ says, whoa, wait a minute, dude, you can't do that because 3 is an R value. It doesn't refer to an object. It is a value itself. Okay, so notice this is an example where it's on the left side of the equal sign, but it's an R value. In other words, again, if you use the test, it doesn't refer to an object. All right, it represents a value. So the bottom line is, the best way to understand is something an R value or is it an L value is check to see if it's an L value. If it's not, then it's an R value. Okay, again, I would strongly encourage you to go dig into these a little bit deeper when you want to understand a little more. If you're brand new to C++, just go with what I've given you so far in the L value references video and the R value references video right here. Okay, so anyway, that's just a real quick overview of R value references. Just kind of stick this in your brain. When you read about them, hear about them, this is what they're talking about. It's the actual underlying, I guess you'd call it architectural description of a particular expression. But I just wanted you to be aware, because you are going to see and hear about this sometimes in some documentation and in conversations in the C++ world.